Hi, this is Jeline from the Honors Tutorial. Our topic for today is about zeros of rational functions for general mathematics under Mathematics 11. Direction is to solve for the zeros of the following rational functions. For example number 1, we have here f of x is equal to x minus 1 over x plus 2. Let us have first the definition of zeros of rational functions. The values where the height of the function is 0, also known as x-intercepts, solutions, or roots. To find zeros of rational functions, set the numerator of the function equal to 0 and solve for the possible values. So for example number 1, the first thing that we have to do is to check if we can still factor the numerator and denominator. So therefore, we will be proceeding with identifying the restrictions. But let me just first write the word solution here. So this is the process that we have to do. Identify the restriction. So we have to focus on our denominator. So that is x plus 2, and then equate it to 0 equals 0. Our goal here is to have x only at the left side of the equation, so therefore, it will become x equals positive 2 will be transposed here at the right side of the equation, then it will become negative 2. So therefore, our restriction here is x equals negative 2. Let's write the word restriction. And then after that, we have to identify the values of x that will make the numerator equal to 0. Now we are going to focus on the numerator. This one, x minus 1. So we have here x minus 1, equate it to 0. And then our goal is to have x only at the left side of the equation. So we have here x equals transpose negative 1 to the right. Then it will become 1. So the value of x that will make the numerator equal to 0 is 1. Now, for the next process, we have to identify the zeros of f of x. We have to compare our restriction, which is negative 2, and the value of x that will make the numerator 0 if they are not the same. Because if they are not the same, we can use this x equals 1 as the zeros of f of x. So, since they are not the same, we will be writing f of x, or let's just write zeros of f of x, that is x equals 1. And that's it. This is the final answer. Next, let us have another example. So we have here f of x is equal to x squared plus 5x minus 24 over x squared minus 64. So same process, we have to check if we can still factor the numerator and denominator because that is very important in this topic. So let's write solution here. And then as you can see, yes, we can still factor the numerator and denominator. They are factorable. So therefore, we will be copying first the given. So we have here f of x is equal to x squared plus 5x minus 24 over x squared minus 64. So since as you can see in our numerator, that is a trinomial, so I want you to prepare two parentheses here. So we have here 1 and then 2. And then also for the denominator, though it is a binomial, but it is factorable. So therefore, we have to prepare also two parentheses here. And it is also discussed in special products how to solve for this. So let's focus first on the numerator. So that is x squared plus 5x minus 24. For the first term, I want you to expand x squared, meaning how many x's do we have here? We have two. So I will be writing one x here and one x here. It is two because our exponent here is two. It is telling us how many x's do we have here, and that is two. Next, for our second term, I want you to think of a number that when you multiply is equal to negative 24. And then when you add the same numbers, that is positive 5. So those are positive 8 and negative 3. If you want to check your answer or your factors, I suggest that you use FOIL method. And then if your answer in FOIL method is x squared plus 5x minus 24, then your factors are correct. Next, for the denominator, as you can see here and notice, x squared and 64 is a perfect square number. So this is for the sum and difference of two squares. Sum and difference, so meaning plus and minus here. And then get the square root of x squared and square root of 64. For square root of x squared, that is x. So let's write x here. And then square root of 64 is 8. So we have here 8 and 8. So this is only the first step. This is for factoring. Let us now identify the restrictions. So that is step 2 here. For the restriction, we are going to focus in our denominator. So that is x squared minus 64. But since we already factored it, then it will become the quantity of x plus 8 times the quantity of x minus 8 now. And then after that, you have to solve for this separately. So let's have x plus 8 first. Let's equate this to 0. So equals 0. X equals transpose positive 8 here at the right side. So it will become negative 8. So this is our first restriction. Then let's find the other value of the restriction. So that is x minus 8 equate to 0. And then let's have x here at the left side of the equation and then transpose negative 8 here at the right side. So it will become 8. We have here two restrictions, negative 8 and 8. Okay, so let's have the next step here. For the other step, we have to identify the values of x that will make the numerator 0. So we will be focusing on the numerator, and that is x squared plus 5x minus 24. Since we already factored this out, we will be using the factored form, and that is the quantity of x plus 8 times the quantity of x minus 3. And then we are going to solve for x. Same process, kindly equate both of them to 0. Then it will become x plus 8 is equal to 0, and then x minus 3 is equal to 0. And then same goal, x will be at the left side, and then this positive 8 will be here at the right side. Then it will become negative 8. For x minus 3, it will become x equals 3. Now we have to determine the zeros of these rational functions. Now, we know the restrictions, that is negative 8 and 8. And then we know the values of x that will make the numerator 0. So we have to compare. So we have here negative 8 and negative 8. So therefore, we will not use this because it is here in the restriction. We cannot have negative 8. That's the meaning of that. For 3, we can use it because it is not here in our restriction. So therefore, we can say that the zeros of f of x is x equals 3. So this is the final answer already for the zeros of the rational functions. So that's it for this part. I know that it is a bit confusing for others and we have lots of solutions for this, but I know that you can do it also. So if you have inquiries, clarifications, and suggestions for us, you can just message our FB page, The Honors Tutorial. So watch out for part 2 of this topic. Thank you and God bless. Bye.